Hey everybody, Mr. Calbeck. Welcome back to school officially. I'm really excited to get a chance to teach you guys today. Your homework assignment for tonight is basically just to watch this video, do the practice problems along with me, and then all you need to do is take a picture of your paper and upload that into the Google assignment. That's all you got to do. As for kind of some expectations, again, I mentioned this on the welcome video. If you've already watched that, I'd recommend to watch it again. But I would just feel free to pause, try the problems on your own. I want to see your work on your homework. I also would recommend that you use printer paper. You guys are all home, so hopefully you have some printer paper. If you don't, it's not a big deal. But I think what you'll find is that printer paper will make your math a little easier to do. The other thing is it's going to make it a lot easier for me to see your work because there won't be other lines and graphs crisscrossing and everything. And if you do need to do some graphing, you're welcome to pull out a piece of graph paper just for that part of it. All right, so essentially today I just want to see if you remember anything about math. It's been over 2 weeks since we've done anything, so I'm just going to see if you remember how to do some problems. We're going to do them together at first, and then I'll give you a couple to try on your own. All told, this video shouldn't take you too long, and if you just follow along with me, your homework's done too. So let's go ahead and see what we're going to do. This is just a review day. That's all we're doing today. And that's it. So, and then we'll try some new stuff. If you're, I think this is a Scarlet Day, so you'll continue this tomorrow. If you're seeing this on Friday, we'll continue next week. All right, I want to see if you guys know how to factor. Okay, so I'm going to, again, I'm going to explain how to do this each time. If you remember how to do it, feel free to fast forward anything that you already remember, but it might be a good idea just for some quick explanations. Don't fast forward something that you think you know, but you're not quite sure. So I'd like you to try to factor this problem right here. And see what you remember how to do. Again, go ahead and press pause and try this on your own. If you don't remember, just keep watching. Okay, hopefully you've tried this one. Let's go ahead and do it together. Remember, when we're doing problems like this, there's an easy kind and a more difficult kind. This is the easy kind. There's a ninja 1 in front of the x squared, which means that we can factor this very quickly. All we need to do is look for numbers that multiply to be 20 and add to be 1. Or sorry, add to be 9, negative 9. So multiply to be 20, add to be negative 9. And if you figure that out, you know that both of these have to be x, and your problem's going to be good to go. So since it multiplies to be a positive, adds to be a negative, I know they both have to be negative, because that's the only way that can happen. And two numbers, and you could just kind of brainstorm. If you're not very good at this, that's okay. I just like to make a little chart and think of everything that multiplies together to be 20. Since I know they both have to be negative, I can make them all negative to start with. So negative 1 and negative 20 work, but that doesn't add to be negative 9. That adds to be negative 21, so that doesn't work. I could do negative 2 and negative 10. That adds to be negative 12, so that doesn't work. Or I can do negative 4 and negative 5, and that equals negative 9, so ding, 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 we've got it. And that's all you have to do for this one. Again, if you forgot this, you could have also done our generic rectangle, which is a great strategy as well. And actually, this is how you would start that. Generally, we usually use a diamond problem, though, to do that. So we would multiply the first and last terms together, because we know that they go right here. So it'd be x squared and 20. So we'd multiply these two together to get the top. And we know they add together to be negative 9. And hopefully you would come up with 4x, negative 5x here, which would then go in the other diagonal of your rectangle. And then we just have to figure out what goes into, or what divides evenly into each column and row. So the first column, the biggest thing that divides evenly into that is x, because they both have an x in it. That means there has to be an x here, because x times x gives you x squared. x times negative 4 gives you negative 4x. X times negative 5 gives you negative 5x. And again, the outside, the dimensions of my rectangle form the same answer here. So I hope you got that. Let's try a little tougher one here. Why don't we try this one and see what you can come up with. Go ahead and press pause and try this on your own. All right, I hope you've tried that. I hope this wasn't too bad for you. There's something that we need to do every time we factor a problem like this, and that's to check for a common multiple. Every single problem you need to check. In the previous one, since we saw there was a 1 here, there couldn't be any numbers that divide evenly here. But this one has a 3, so I'm going to check to see if all 3 of these are divisible by 3. And it turns out that they are. And what we want to do is we want to, as we divide, so there's no equal sign, we can't do it to both sides. But what we can do is we can undistribute a 3. So instead of multiplying a 3 into parentheses, you can think about undistributing the 3. You can divide the 3 out of the parentheses, which would put it here. Once we divide it, then we say, okay, what's left? 3 divided by 3, that's just a 1x. 21 divided by 3 is 7. 30 divided by 3 is 10. And so we're left here with something that's not too bad to factor. We see this is actually really similar to the last problem, except the numbers are actually easier. We see there's a 1 here, so it's the easy kind of factoring. You don't need a generic rectangle. All we need to ask ourselves is, what multiplies to be positive 10 and adds to be positive 7? And those are going to be your answers. Remember that 3 stays out in front. The mastery quiz, I'm sure you guys remember messing that up and having to retake it. So let's try here. So we've got x and x, because we know that x times x gives you x squared. What multiplies to be 10 adds to be 7? This got to be 2 and 5. So we're going to have x plus 2 and x plus 5. Also, the order of the parentheses doesn't matter. Okay? And again, if you're having trouble with this, there's no shame. A lot of times what I'll do, I'll just make a chart over here. Again, what multiplies to be 10 and adds to be 7? You can make your little chart. There's not a lot of options here. And we know they both have to be positive since everything in here is positive. So you don't have to consider any negative cases. So you do 1 and 10 or 2 and 5. Oh, 2 and 5. We got it. Okay, and that's what's in your answer. All right, let's try one more difficult one here. Try this one. So we've got 3x squared plus 14x minus 5. All right, go ahead and try this one on your own. Again, press pause. All right, if you think you got this, you can fast forward about 1 minute and you'll see the answer. But this one, again, we always want to check to see if there's a common multiple, and there is nothing that divides evenly into all 3 numbers. So, not going to work. And there's no 1 here, so we're going to have to go to the generic rectangle option. So we know that goes in the bottom left, this goes in the top right, and they are going to multiply to make this top number. 3x squared times negative 5 is negative 15x squared. And the bottom number is the middle one, 14x. Now, a couple of quick observations. Since it multiplies to be a negative, I know that 1 is negative and 1's positive. So that should help you narrow down the multiplication factors. We're going to see what we can come up with here. What multiplies to be negative 15 and adds to be positive 14. I'm going to try 1 and 15, and I've actually already got it. The only trick is I have to make sure the 1 is negative so that it adds to be a positive 14. Okay, so I'm going to make 1x and 15x, and now we have our other diagonal. By the way, if you are watching this video and you don't know how to factor, and you never learned this particular method, I have a whole crash course series on my website called the Factoring Crash Course. I think there's 6 videos on there that will teach you how to factor without any sort of rectangle, diamond stuff. It's another method altogether, and if you would like to learn that method, if you weren't in my class or you're watching this another time, I'd recommend that you go ahead and check that out. I'll put a link in the description for you. So we've got negative 1x and 3x squared. We're going to find the biggest thing that divides evenly into both of those. So x and x squared, that makes an x. X times 3x gives you 3x squared. Remember, the outside has to multiply to be the inside. X times negative 1 gives you negative 1x, and 5 here. You can always check your work. Because these two should always multiply to be this one. And they do, so we factored it. We got x plus 5 and 3x minus 1. Again, the order of the parentheses doesn't matter. All right? Give me a thumbs up if you got that one right. Hey, it's great to see all of you out there. Give me a thumbs up. All right, let's try one last one here. And I want to see if you guys can factor this on your own. I'm not going to show you how to do it. It's just a quick practice one. All right, go ahead and try this on your own. I'll write the answer down in just 1 minute. All right, hopefully you've tried this one. The answer to this problem is 2x plus 1 and x plus 3. I hope you got that. All right, let's move on to the next part of our review. The other thing that we were working on right before break is we were learning how to graph in Vertex Form. Okay, for those who have not done Vertex Form is a way that you can write a quadratic function. Again, a quadratic is the name for the equation that gives us a parabola when we graph it. There's several different ways of writing parabola or quadratic equations. You've already seen 2 of them in the last problem. Okay, these are 2 different ways of writing quadratic equations. If you make them equal to y, now you have an actual equation. The top form is called standard form, if you remember that. That's standard form on the top here. And the bottom is called factored form. Both are useful in different ways. Standard form is this form that you're most likely to see in a problem that I give you on a test or quiz. By the way, there's still tests and quizzes in this. They won't be super long, but we will be giving you assessments still. And so that way you can still have a grade and you still get credit for this class. There will not be a final, however. So you don't need to panic about a final. You will be tested on some of this stuff though. So make sure that you're following along and doing this stuff. Standard form is going to give you again, a couple of interesting things. It's going to tell you the shape of the parabola from this number right here. We usually call this the a value. Another way that we sometimes will write standard form is like this. Say ax squared plus bx plus c. In fact, this is a very common way of thinking about it. This is really similar to saying a linear equation is y equals mx plus b. The m and the b always stand for numbers, and in the same way, a, b, and c stand for numbers as well. You're not going to see equations with those as variables. The only variables you'll ever see are y and x, and a, b, and c will always be numbers. The a value tells you the shape of your parabola. If a is positive, you're going to have a smiley face parabola because, let's be honest, positive people are just happier. If a is negative, it will be a sad face. The bigger A is, the steeper your graph becomes. So it will appear skinnier because it's going up more quickly. So if you have, for example, 3x squared in the front here, that's going to be a positive, and it's going to look really skinny. And if you want to try that in your graphing calculator right now, you're welcome to do that. If you have a number that's less than 1, so maybe 1/3 x squared, what will happen there is you're going to have a wider graph. It's not going to go up as steeply because there's a 1/3 there. Think about it, it's similar to a slope, whereas slope goes up less steeply when it's a smaller number, goes up more quickly when it's a bigger number. Again, there isn't really a slope per se on a parabola because it's curving, it's nonlinear. Slope applies to linear only, but it's the same idea of steepness. Okay, factored form tells us a couple of other things. Factored form tells us the X-intercepts. Oh wait, one other thing. The C value also tells us something really nice. The C value is always going to be your Y-intercept. Okay, and that's because the Y-intercept happens. Class, when does Y-intercept happen? You can shout it out at your screen right now. Y-intercept happens when x equals 0. So when x is 0 in this original equation here, 2 times 0 gives you 0. 7 times 0 gives you 0. So the only thing left is the 3. That's why it's your y-intercept. So every time you see a number that doesn't have an x on it, in any equation actually, it's going to be your y-intercept. All right, the factored form is going to tell you your x-intercepts. The x-intercepts happen when the y value is 0. So we can set that up over here. So if we were to do that exact same problem, we had 2x plus 1 and x plus 3. And if I wanted to find out if this is where this equals 0, what I want to do is set each of these pieces equal to 0. So I want to say, all right, when 2x plus 1 equals 0 and x plus 3 equals 0. And the reason for that is a product called the zero product property. We've talked about that a lot in my class. You're welcome to look it up online if you are watching this and you've never heard of the zero product property. It's a pretty simple idea. Zero product. Come on, Calbeck. Calbeck is already attacking in the first video. That's ridiculous. Zero product property. I'm sorry. Basically, the idea is if you have two numbers that multiply together and they equal 0, you know one of them or both of them has to be 0. That's what the zero product property says. And even though it doesn't look like it, that's what we've got here. I've got two numbers. Now the number looks weird, but that's just a number. 2x plus 1, whatever x is, this is going to turn into a number. And this is also going to turn into a number. So I have two numbers multiplied together that equals 0. So I know one of them or both of them has to be 0. And then you have two equations. You just have to figure out what x is that turns each of these numbers into 0. Again, this is a number. So x has to be a certain value to make it 0. Subtract 1 from both sides. You end up with 2x equals positive 1. Divide by 2. And you can get x equals negative 1/2. Over here, it's a little easier. You subtract 3, and you get x equals negative 3. And those are your two x-intercepts on this parabola. Okay? So that's kind of what you get. Between standard form and factored form, you learn a lot about your parabolas. You can graph them pretty well. But there's one other form of a parabola that we talked about a lot in this class, and that was vertex form. Vertex form is different altogether than what you've seen before. It looks like this. It's y equals a times x minus h squared plus k. Now, two of these you've never seen before, the h and the k, but you have seen the a before. It's the exact same a as you saw in standard form. Same number, same meaning as well. It's going to tell you the shape of your parabola. It's going to tell you whether it's right side up, upside down, steep, or not steep. Okay, so we already actually know what the a value does. It gives you the shape of your parabola. The h and the k values are really nice because they tell you where the vertex of your parabola is. H is the x coordinate of your vertex. And k is the y coordinate of your vertex. All right, and so what you might see is something that looks like this. Y equals 2 times x minus 3 squared minus 2. All right, so that's what your equations might look like. Do notice that the h is always subtracted, so it will be the opposite of what it appears to be. This says minus 3, which means that the h was actually positive. It's always the opposite. So the vertex of this particular parabola would be at 3, positive 3, negative 2. That's the vertex. And it's twice as steep as a normal parabola. So that's essentially what we're doing here, and I'll show you real quickly how we would go about graphing something like that. Go ahead, I'm going to pause this real quick and get my graph paper. All right, I think we're recording again. So we just had that equation. Hopefully you still got it somewhere on your paper. Okay, so that's our equation, negative 2 times x minus 3 minus 2. So my vertex is going to be at 3, negative 2. So I'm going to go over here and put a point at 3, negative 2. So the vertex is right there. That's pretty glary. I'm sorry. I'm not sure how to fix that right now. Yeah, I'll do my best. Okay. So that's where the vertex is. Now the trick is, how does your parabola go? We know it's steeper. Like, do you just draw it and be like, I hope that's right? Absolutely not. We're never just guessing in math. There's reason for everything that we do. And you can always do exact points very easily if you remember the parent function of your parabola. Okay, parent function of any type of graph is the simplest, most obvious case of a parabola. In our case, the parabola is y equals x squared. That's the simplest case. It's the parent function. I like to think of it as the mother function. I wouldn't recommend you saying that to your family, telling you Mr. Calbeck is using the word mother function repeatedly in his videos. But yeah, it's a mother function. Okay, it's the function that you think of every other function that's a parabola is like a child or of this particular parent or mother function. All right, so if we learn about this one, everything else is simply what we call in math a transformation of this graph. And so if we want to figure out what any parabola looks like, we just need to figure out what this one looks like and change it a little bit, transform it. So what I've taught my class before, again, if you see this, this is really obvious. We've talked about it a lot. You feel free to fast forward about 2 minutes, and I can show you how to graph it. If you've never seen this before or you forgot it, feel free to watch through. But I'm going to plug numbers in for x and see what I get for y. So if I plug in negative 3, and I'm just going to plug in all these different numbers here for x. So negative 3 squared is going to give me positive 9, because negative times a negative is a positive. So I'm going to put a 9 here on my table. Negative 2 squared, that's negative 2 in the parentheses here. Negative 2 squared is 4. And negative 1 squared is 1. Lastly, we get 0 squared. 0 times 0 is 0. And now we can go up the list here. 1 times 1, or 1 squared, is 1. 2 squared is 4. And 3 squared, again, we're plugging all these numbers in for x, that's why I'm squaring them, is 9. Okay, and this pattern continues. You may see that where the pattern comes from. You're simply squaring this number whatever the x is, and that gives you your y values. But I want you to think about the 0, 0 term as being the vertex. Okay? Because in the parent function, it is. If we graph it, it sits right here and looks like that. So if we move the vertex, what this now represents, again, because we're transforming the parent function. So what this represents now is the distance from the vertex. So -1, 1, -2, 2. That's how far away you're going from the vertex left and right. This is how far you go up from the vertex. So let me show you what that looks like when we're graphing. We've got our vertex here. Move it down, maybe you can see a little bit better. The parent function tells me that when I move 1 away from the vertex, left and right, so -1 and +1, I go up 1. So I'm going to go over 1, up 1. The parent function says when I move -2 and +2 from the vertex, that's left and right because it's the x coordinate, I go up 4. And again, I'm going from the vertex, so I go over 2 and up 4 from the vertex. The third one would be 3 away, so +3 and -3, and again, I'm going from the vertex always. And I go up 9 this time. 3, 4, 5, 6, 7, 8, 9. Okay, and we see our y-intercept show up there. And that's what our graph looks like. And some of you are thinking right now, you're like, wait a minute, I think you messed up, Calbeck, because there was a 2 in front of this graph. You're absolutely right. There was a 2 in front of the graph. If we looked at our original function again, the a value was 2. And what that does, essentially, to my pattern, the parent function, is it takes all of the y values and doubles them. So instead of 0, I get 0 times 2, which is still 0. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. So what I would do here, instead of having, because of this 2, instead of having it go over 1, up 1, now I'm going to go over 1, up 2. It's going up twice as steep. Instead of over 2, up 4, I go over 2, up 8. Sorry, 1 too many. And instead of going over 3, up 9, I would go over 3, up 18. I don't have room on this graph for that. So what you're going to see is a steeper parabola that you can graph specific points for. So this blue one is the parent function that I transformed, and the green one is my actual graph. All right, so let's try one on your own. I want you to see if you can graph. Let's see here, do I have any space left? Yes. Go ahead and see if you can graph this one on your own. I'm going to make it a little bit challenging for you. All right, go ahead and try that one. Press pause and see what you can do with it. All right, let's see what you can try here. With my equation, let's find the vertex first. I like to write the vertex down, so that way I make sure I get it right. Remember, the x coordinate is the opposite, so that means my vertex is going to be at -2. The y coordinate is not opposite. It's going to be +4. Try that right there. So -2, 4. So I'm going to go ahead and plot that on my graph. -2, +4 is right here. Sorry, there's like a scratch on my whiteboard, so that black dot doesn't mean anything, and I can't erase it. I apologize. And the pattern here was negative and the a value was negative, so it's going to be upside down, and it's 1/2, which means I take all of my original numbers here, the ones in blue, and I multiply them by 1/2. So instead of them being 0, 1, 4, 9, going to be 0, 1/2, because 1 times 1/2 is 1/2, 4 times 1/2 is 2, 9 times 1/2 is 4.5, and those are my new points that I graph. Again, the distance up and down, distance left and right. Notice the x values never change on my pattern, only the y values do. So I can go ahead and graph this, and remember that it's going down this time. So I would go over 1, down 1/2. That one's kind of a little difficult to graph, but it's not too bad with 1/2. Over 2, down 2 instead of 4, because it's half as much. And over 3, down 4.5. And if I were to go the next one over, 4 squared is 16. So 1/2 of 16 would be 8. So that would be down at -8. Or -4 rather. Okay, and there's my parabola. It's a wider parabola than you would see that we did on the other one. All right, let's do one more, and we'll try this one on your own. There you go. Go ahead and graph this one right now. I'm not going to walk through step by step. I will show you the answer though. So press pause, try it. Hopefully you tried it. Your vertex should have been at -1, -4. And this one's 4 times steeper. So I go over 1, up 4. Over 2, usually goes up 4, be up 16. Actually, I don't have space for that on this particular. Actually, I do. That's right. Let's see. 1, 2, 3, 4, 5, 6, 7, 16. I do have space. Hey, cool. Look at that. This one is very, very steep. All right. Nice. That's it for our review lesson for today. But I do have one more bonus question that we're going to talk about next time, and I want you to get started on this on your own. Okay? So here is the bonus question. And what I want you to try to do is, by using factoring and standard form, I want you to see if you can graph this equation. I don't want you to just type it in your calculator and see if you can figure out how to do it and just like copy it down. And I don't want you to guess and check with a table. See if you can use your best understanding of the way parabolas work, the patterns of the parent function, the X-intercepts of factored form, and everything else. And just see if you can figure out how to graph this one. I want the location of the vertex, the X-intercepts, and at least 2 points on either side of the vertex. All right, one of those is probably going to be your X-intercepts, maybe Y-intercepts. You can get a lot of this stuff on your own, but I want you to see what you can do. You do have to find the vertex. So I want you to try to figure this out. Okay? And we'll talk about the answer to this next time on our video. If you remember how to do this, congratulations. We did this in class before we left. I want you to try to graph this best you can. I do want the vertex. And at least 2 points on either side of the vertex. And your hint is to use factored form. And we'll talk about the answer to this next time. Hope you guys have an awesome day. Feel free to shoot me an email with any questions. My office hours every day are going to be from 11 to noon as of right now. And if that isn't working for you, feel free to send me an email. I'd be happy to set up another time that we can meet. We can do a Google chat, and that would be kind of fun too. So I hope to see you guys soon.